Hello everyone. In this video, I will be present my solution for SAT 331 Task 4.2C, Repository Pattern and Object Relation Mapping. In the previous task 4.1p, we implemented a persistence layer that connected the API to PostgreSQL database using ADO.NET and SQL data reader. However, this approach still tightly couples the application with the data access implementation. The goal of the task is to further decouple the system by introducing the repository pattern and basic object relation mapping. ORM. The repository pattern allows us to separate data access logic from the application layer by introducing interfaces and repository classes. In addition, a lightweight ORM solution using the fast member library is implemented to automatically map database records to application entities to improve maintainability, reduce code duplication, and allows the system to easily switch between different persistent implementations. So, to complete this task, I extended my project 4.1p. First, I have installed the fast member library using the command .NET add package fastmember.signed. Next, I refactored the existing persistent layer by applying the dependency inversion principle. Previously, the controllers directly depend on concrete data access classes. To solve this, I extract interfaces from data access classes. For example, robot command data access, map data access. These interfaces define the method signatures used to interact with the database. Then I renamed the original ADO data access classes to robot command ADO and map ADO. After that, I implemented repository classes that provide ORM based instructions. These robot command repository and map command repository. These repositories use a generic method defined in iRepository interface that is here. So this is our complete generic method. This SQL queries and to interface to execute SQL queries and automatically map results to entity objects. Finally, dependency injection was configured in program CS so that controller receive the repository implementation automatically. So this is our dependency injection. Now I will briefly explain the key parts of the implementation. Data access interfaces. The first step was extracting interfaces from the data access classes. For example, robot command dataaccess.cs. The interface defines methods such as get robot commands, get robot command by ID, add robot command, update robot command, delete robot command. Controllers interact with these interfaces instead of concurrent classes. These allow us to change the persistent implementation without modifying the controller code. Next, dependency injection is configured inside the program.cs. This means whenever a controller requests the interface, the system automatically injects the repository implementation. So the generic repository method. A reusable generic repository method is implemented in repository.cs. This method executes SQL queries and return mapped entities of type T. The method performs the following steps. Connect to PostgreSQL using npg SQL, execute the SQL command, reads database records, maps them automatically to entity objects. Next is the object relation mapping. To perform automatic mapping, we created an extension method called in the program CS map. Sorry, in the repository CS. This method uses the fast member library to match database column names with entity proper names. For example, database column is move command. Entity property is move command. This mapping happens automatically without manual assignments, thus significantly reduce repetitive code compared to the previous implementation. So now I will demonstrate the complete API functionality by testing the endpoints. So our code is successfully run. So our method is successfully implemented using status code 200. These are all the robot commands. Now we can also use move command. So we will show the move command is currently not available. Now we can also fetch it using the ID. For example, write updated move command. We can also check for an invalid ID. Here we can clearly say robot ID 1991 nose down with status code 404. Now let's try by using a post command and add an ID. As if the ID is created successfully, we can also check using the get command. Here you can clearly see the ID is created successfully. Now let's update any ID. Suppose we are updating a ID number 3 move with using the put command. So it is get updated. We can also check using the get command. Here you can clearly see move is updated. Now we can also delete any command. Let's delete the back command we have currently posted it. So we get 0 for no conflict. Let's check it through the get method. As the ID is deleted successfully, as you can see. Now we can also test map endpoints. Here is our map endpoints. We can also fetch it by ID. Similarly, if we put an invalid ID, we will get 404 not found status. Similarly, we can put a map ID and delete a map ID similarly. So to conclude, in this task, we implemented the repository pattern and object relational mapping in the persistent layer. Improved the architecture by separating data access logic from the application layer and enable flexible switching between implementation. The fast member-based ORM automatically maps database records to entity objects, reducing manual coding and improve maintainability. All endpoints were successfully tested, confirming that the repository implementation works correctly. Thank you.